Welcome to today's lesson. In this tutorial, we will graph linear equations in slope-intercept form using tables. So let's look at situation number 1 and graph this linear equation. This linear equation is in standard form, so we like to graph those using x and y intercepts. Let's go find the x-intercept first and see what happens. The x-intercept is when y equals 0. So I would have 5 times x plus 0 is equal to 6, because 2 times 0 would go away, or simply 5x equals 6. If I divide by my coefficient, I will have my x-intercept, which is 6/5, or rather 1.2. Now I don't really like this because I would have to approximate exactly where 1.2 is. Where is 1.2? Somewhere around there. So maybe this is not the best method. Graphing by x and y intercepts is maybe not the best method. Perhaps we need a new method, and that's why we're going to explore a table of values today. But to be able to use a table of values, we must solve for y. So now let's solve for y. Let's take this equation, 5x plus 2y is equal to 6, and let's solve for y. To solve for y, the first thing we need to do is move this x term. So let's subtract 5x from both sides. Notice that I put the negative 5x right underneath its like terms because these are like terms, they cancel away. But I did not put them underneath each other here because 6 and negative 5x are not like terms. So 2y will be all by itself on the left side. I like my variable term to be first, so I'm going to put the negative 5x first, and the 6 will just push aside and still be positive, so I need that plus sign. One more step, let's divide by the coefficient. We'll divide each term individually by 2. This will cancel away here, and I will have y equals, which is exactly what I wanted. This first fraction does not reduce, so I will just keep it as a fraction, negative 5/2 x. This second fraction does reduce. 6 divided by 2 is 3. So now I have solved this equation for y, and that's another special form of our equation. It's called slope-intercept form. When we solve for y, we have our equation as y equals mx plus b, where m is our slope and b is our y-intercept. We're going to explore these concepts a little bit later. Let's also talk about function notation, because today you're going to see this symbol, f of x equals, or this symbol, g of x equals. Both of these symbols mean the same thing, they're just fancy names for y equals. We read this symbol as f of x, and this symbol as g of x. But again, both of them mean the same thing, they just stand for y. So let's practice evaluating some of our functions for given values. The equation that we just solved for y, let's call it f of x, and that's equal to negative 5/2 x plus 3. Remember, this is just a fancy name for y. If I want to evaluate f of negative 2, that means that my x variable will now be a negative 2. So I'm going to substitute that right into the equation right here for our x. So let's do that. F of negative 2, and that's how you read that symbol. We're going to write exactly what we see here, except instead of an x, we're going to plug the negative 2. So negative 5/2 times my negative 2 plus 3. And this will just be a number, so let's see if we can go find it. Since I'm dealing with fractions, maybe I'll put this over 1, so I can clearly see that the numerators are negative 5 times negative 2, which is 10, divided by the denominators, which are 2 times 1, which is 2, and then plus 3. 10 divided by 2 is 5, plus 3. And when I add those, I get 8. So I input a negative 2, and I output an 8. So my input is a negative 2, and my output is an 8. So I have one ordered pair that's on my line. Let's evaluate f of 4. It's similar, it's just that we're plugging in a 4 instead. So this value of 4 is going to come right in here in place of that x. So let's see what happens here. Negative 5/2 times, instead of x, it's a 4 this time, plus 3. Maybe we put that over 1, so again I can see my fractions. Negative 5 times 4 is negative 20. 2 times 1 is 2, plus 3. Negative 20 divided by 2 is negative 10 plus 3. And then when I add this, I get negative 7. So when I input a 4, I output a negative 7. So that's another ordered pair that I would have to graph my line. I do have one more row that I can fill out, and let's plug in a 0. Let's find f of 0. I always like plugging in 0 because it seems pretty simple. So f of 0, I have negative 5 halves times 0 plus 3. Well, anything times 0 goes away. That's why this is sort of simple. And when we add 3, we get 3. So f of 0 is 3. When I plug in a 0, I output a 3. So that's how we can evaluate our functions, and we can do it by hand. Let me show you a different method, and let's change our function to g of x equals 3x minus 5. If we wanted to find g of 0 and g of 3, we could do that by hand, or let's try and use our Desmos calculator. Let me slide this down a little bit so we can see. If we pull up our Desmos calculator and simply type in the equation g of x equals 3x minus 5, once we type in that equation, we can type in any of the g of 0 or g of 3 values that we want to find. So g of 0, and Desmos will instantly give me my negative 5 as my output. So that might be much faster. When I plug in a 0, I get negative 5 as an output. I can either press enter or press down and find another one. Let's do g of 3. So we just have to type g of 3. G of 3 will give me a 4 as my output. So that's simple. 3 goes in, 4 comes out. We have another spot. What would you like to plug in? We've plugged in a 0. We've plugged in a positive. How about we plug in a negative? How about g of negative 1? Let's see what happens here. Again, push down or enter and type in g of negative 1, and we get an output of negative 8. So when I input negative 1, I output negative 8. So we can use Desmos to make this process a little bit easier. Okay, now that we know how to generate a t-table or a table of values, let's graph some. Let's graph each of the following linear equations by using our table of values. So I've changed my function back to f of x, and it's a different function. It's 2/3 x minus 1. So when I go to Desmos and type this in, let me move this up a little bit so we can see it. First of all, I can clear these out individually, or I can just keep writing. It doesn't really matter. I'm going to clear them all out. Let's type in my new line, f of x is equal to, when I need a fraction, I usually just type the division. So there's my fraction, 2/3, and we've got x and then minus 1. So it obviously already gives me the line, and I can check that when I do this. But what I want to do is convert it to a table. So when I go to my, let me go back. When I hit this gear, it says edit the list. If I click on that, there's an option to convert to table. When I click that, it's going to give me 5 points for x, and it'll always be -2, -1, 0, 1, and 2. And then it'll give me the outputs for those 5 inputs. I don't really like these outputs because they're decimals. And they're decimals because I'm ultimately dividing by 3. So plugging in a -2 and a -1 does not really make sense because those are not divisible by 3. So what I can do is I can just keep adding to my table. Numbers that are divisible by 3 are numbers like 3. See, that's going to be a nice output. And if I keep going, how about -3? Another nice output. Maybe I jump up to 6. That's going to be another nice output. Or maybe a -6. And I can keep doing that because these numbers are divisible by 3. These are better inputs, and I get better outputs. So let's see what we've got. I like the 0, 0, -1. I'm going to put that right in the center of my table, 0, -1. And let's go back and look at my table. Let's get the good values. So if I plug in a 3 and a 6, right, I get a 1 and a 3. So if I plug in a 3, I get a 1. When I plug in a 6, I get a 3. I'm just looking at my table of values from Desmos. When I plug in the negatives, -3 gives me a -3, -6 gives me a -5. So -3 gives me a -3, and -6 gave me a -5. Again, this is in Desmos, and it converted to a table. Convert to table. That's going to be very helpful. Now, if I tried to plug -6, -5, 1, 2, 3, 4, 5, I'm just a little bit off the graph patch, and it would be down about right here. And -3, -3, -1, -2, -3, -1, -2, -3 is right there. 0, -1 is this ordered pair right there. 3, 1 is right there. And 6, 3, again, a little bit off the graph, but that's okay. 1, 2, 3. The more points, the better. And these all are connected in a nice straight line. And let's put arrowheads on that line. So we plugged this into Desmos, we generated a t-table from Desmos, and we plotted those 5 points onto our graph patch and connected our line. Pretty good. Let's look at example 5. This one is a little bit different because this is not yet solved for y. To use a t-table, to use a table of values, we need our equations solved for y. So since I'm solving for y, I need to get rid of this coefficient and get rid of this term. Terms go first. So let's add 2 to both sides. This will go away. 4x and 2 are not like terms, so I will write them side by side. I like my x term to be first, and then this positive 2 will be second. This is equal to 2y. I have to now divide by 2, and I will divide individually each term by 2. This will cancel away. If you don't mind, I'm going to write the y first. And then I've got 4x divided by 2 becomes 2x, and 2 divided by 2 becomes 1 with the plus sign. So now I have solved this for y. Maybe we give it a name like g of x, so we can use that in Desmos. So g of x equals 2x plus 1. Let's go back to Desmos and type that in and see where we are. Put that right there. I can go to this gear and delete everything that I've done so I can start fresh, and that's what I'm going to do. So let's type g of x equals 2x plus 1. If you're not on Desmos, I encourage you to do that so you can type along with us. So once I have my equation, I'm going to go to my gear and convert it to a table. And now I have this t-table of values. And all of these are nice values, not decimals this time. So I'm going to use them. So I know my x's go from -2 to -1 to 0 to 1 to 2. And let's see what my outputs are. -3, -1, 1, 3, 5. Okay, I've got it. -3, -1, 1, 3, and 5. Great, I've got 5 ordered pairs that I can now graph into my graph patch. -2, -3 is here. -1, -1 is here. 0, 1, 1, 3, and 2, 5. Check to make sure these are all on the same line, and they are, and then connect them with a nice straight line and put your arrows. Perfect. Let's try one more. This one is already solved. It says h of x equals 3. Again, that's just a fancy name for y equals 3. And this is one of our special types of lines. Let's see what Desmos says about it. I'm going to come down here and you know what? I'm going to delete everything I've just done. And let's type in h of x is equal to 3. Well, there's our line. I bet you knew that it was going to be horizontal. Let's convert it to a table and see what happens. Yep, look at all these y values. They're always going to be 3 because that's what it says, y equals 3. It does not matter what the x values are, y will equal to 3. So if I type in, or if I plug in a -2 or a -1 or a 0 or a 1 or a 2, I will always be getting an output of 3. And when I plot all of those points, I will get 5 points at least on a nice horizontal line. Let's connect them all and put our arrows, and that's it. Thanks for watching this tutorial. We will practice this in Desmos, and I'll see you in class. Bye-bye.